So good morning everybody, myself Acharya Vishvendra, and today I am going to discuss a worksheet on organ pipes. So let's begin with the worksheet. So here is the worksheet over here. So the first question is what are the types of organ pipes? So organ pipes are basically of two types: open organ pipes and closed organ pipes. Open organ pipes mean open from both ends. Enclosed organ pipe means closed at one end only. So that is the standard convention behind organ pipes. Next is fundamental frequency of closed organ pipes. So the fundamental frequency of closed organ pipe is V by 4L. Next is fundamental frequency of open organ pipe. It is V by 2L. Next is frequency of nth harmonic of open organ pipe. So it is Nv by 2L. Next is frequency of nth harmonic in closed organ pipe. So it is Nv by 4L. Next is nth overtone. So this is n plus 1th harmonic of open organ pipe, and nth overtone is 2n plus 1th harmonic of closed organ pipe. Next is speed of sound is 300 meter per second, length is 3 meter. We need to find fundamental frequency of closed organ pipe. So it is V by 4L. After substituting we get 25 Hertz. Next is fundamental frequency of open organ pipe. So it is V by 2L. So that is 50 Hertz. Next is frequency of first overtone of open organ pipe. So first overtone means second harmonic. So that will be twice of V by 12. So 2 into 50, which will be 100 Hertz. Next is frequency of first overtone of closed organ pipe. So first organ overtone means third harmonic will be there. So it is 3V by 4L. So that is 75 Hertz. Next is frequency of nth harmonic of open organ pipe. So it is Nv by 12, so 50N. Next is frequency of nth harmonic of closed organ pipe. So it is Nv by 4L, so 25N. Next is wavelength of sound in fundamental mode of open organ pipe. So L here is lambda by 2, so lambda will be twice of L, that will be 6 meter. Next is wavelength of sound in fundamental mode of closed organ pipe. So in fundamental mode, length will be L by 4, lambda by 4. So from here lambda will be 4L. Next is we are being given an organ pipe and a water is filled in it. So tuning fork is vibrating in that, and first resonance takes place at L1 length, second at L2 length. Then we need to find wavelength of sound. So the wavelength is twice of L2 minus L1. Next is N correction. So after calculations it comes out to be 3L1 minus L2 by 2. Next is frequency of oscillation. So frequency comes out to be V by twice of L2 minus L1. Next is dimension of frequency. It is M0 L0 T minus 1. Dimension of time period M0 L0 T1. Dimension of lambda M0 L1 T0. So these worksheets are just the basic testing mechanism to check your basic learning. Here we have not discussed any sort of derivation or any calculations. That we will discuss in later videos, and there are videos available for the derivation parts. Here it's a sort of testing mechanism, or just checking for the very basic and fundamental information, fundamental patterns related to various chapters. So you just use these worksheets as a sort of testing mechanism, simple testing that test your the basic concepts, the basic vocabulary, and are you able to retain all those things when asked in a number of questions. So just use these worksheet when you have completed your study and you want to check that whether you have studied effectively or not. So as you can see, these questions are very simple and based on psychologically designed patterns, just to make sure that you are strong fundamentally, so that you can answer to the next higher level questions. In the proceeding videos, we'll be making videos with more complex questions, more complex situations, but gradually. These are the level 1 worksheets. So use them as an optimization tool to check your working, to check your study patterns. Thank you and have a nice day.